Over the next two videos, we're going to be learning the naming system that is used for ionic compounds. The first thing that we'll need to do is identify whether the compound that we're naming is indeed ionic, and the way to do this is simply to see whether the compound is made up of a cation, which is a positively charged ion, and an anion, which is a negatively charged ion, and we can see from the Lewis structure that NaCl clearly fits that description. Now, most of the time, the positively charged ion is going to be some sort of metal. So if there is a metal within the compound, there's a very, very strong chance that you're dealing with an ionic compound. The anion, however, can be a single nonmetal, as it is with our sample compound NaCl, but as we'll see in the second half of this video, that is not always true. Now, the first stage of naming this particular compound is to find the name of both the metal and the nonmetal on the periodic table, which we can do relatively easily. So we can see here that the name of chemical symbol Na is sodium, and the name of chemical symbol Cl is chlorine, and those two names, one after the other, will make up the starting point of the name for this compound. However, sodium and chlorine are the names of the individual elements that are separate from each other, and therefore we need to make a modification specifically to the nonmetal's name in order to designate that this is part of a compound. So what we're going to do, or rather what I've already done, is I've removed the suffix from the nonmetal here. So the suffix depends on the name of the nonmetal itself. For example, if we want to remove the suffix for oxygen, we would remove most of the name oxygen itself, but in the case of halogens like fluorine, chlorine, bromine, and iodine, we simply remove the INE, and to designate that the nonmetal is an ion and part of a compound, we replace it with the suffix IDE, which gives us the technical name for table salt, sodium chloride. However, with our second compound, we can see that there's a much more complicated structure that forms an ionic bond with sodium. And indeed, if we write the chemical structure of this complicated anion here, it has the chemical formula NO3 with a -1 charge. Now, this compound here that takes the place of the anion in our ionic compound is what we call a polyatomic ion. And those of you who are skilled with identifying meanings of components of words can basically figure out the meaning of polyatomic ion just by breaking up this word. So poly is the prefix that indicates whenever we have multiple or more than one of something, in this case more than one atom that are all together, and the fact that they are an ion means that they have charge, and that description perfectly matches NO3 with a -1 charge. And we can see all of the examples of polyatomic ions below all fit this description as well. So polyatomic ions are simply a group of atoms when arranged in a specific arrangement together. The atoms all together have a single charge and therefore behave the same way as an anion that is a single element behaves, meaning that because sodium has a +1 charge and this thing, NO3- has a -1 charge, the two can form an ionic compound together. Now, even though polyatomic ions structurally can be quite complicated, naming them is actually very straightforward. We can name this compound by starting off naming the metal. We already know the name of Na is sodium, so we can go ahead and name that, and then all we need to do is actually find the name of the polyatomic ion with the chemical formula NO3, which we can do with this conveniently placed table of polyatomic ions. There's NO3 right there. Now, in terms of where you can actually find this table of polyatomic ions, if we go to the periodic table, we can see that the table of polyatomic ions is right in the top center here, and most periodic tables will have this either in the periodic table itself or on the back page as a quick reference, because again, memorizing the names of all of these polyatomic ions is not an efficient use of time. So all that we need to do is find the name of the polyatomic ion. In this case, it is nitrate. And then once we write the name of the polyatomic ion, we are actually done, and we don't need to modify the name of this compound at all. When sodium and nitrate are put together, the compound that it makes is simply called sodium nitrate. This concludes the first half of the naming rules of ionic compounds. Before we move to the second half, you can try the practice problems below, which are all examples of ionic compounds containing a metal and potentially a non-metal, although many of them, as you'll see, are a metal and a polyatomic ion instead. But once again, every single one of these compounds follows the rules that are outlined in this video here.